Hey everybody, I'm wearing a comfy onesie today. It's a Care Bear. I'm not sure if any of you even know what that is. I hope you do. But I'm actually sweating, so I'll make this fast. We are going to do 9.7 notes, perimeters and similarity. Make sure you have that out, and a pencil, and get yourself ready to learn. And here we go. Our notes here, perimeters and similarity. This theorem here, if two triangles are similar, then the measures of the corresponding perimeters are proportional to the measures of the corresponding sides. If triangle ABC is similar to triangle DEF, then the perimeter of triangle ABC is proportional to perimeter of DEF, meaning all the sides are going to be proportional as well. So, for this first example, number 1, the perimeter of RST is going to be 9. And we know these two triangles are similar. So find the value of each variable. So to find the perimeter of this top triangle, MNP, I am going to add these all up. $13.5. I'm going to put that on the bottom, and now I can set up proportions with different ratios. So RS, this line, is going to be proportional to this one. So I'm going to do x over 3. I can cross multiply. 27, 13.5, x. X equals, and I get 2. So this side is 2. Now I can do another proportion with 9 over 13.5. And remember, these are my perimeters, the 9 and the 13.5. So I'm going to take Z from RST and 4.5. Going to cross multiply. I have 40.5 equals 13.5 Z. Divide. And I'm going to get Z equals 3. Alright? And technically, I could do a whole nother proportion. I will show you that, but 3, 4, 5, I know my perimeter is 9, so this is going to end up being 4. But let's just check really quick to make sure. I have 9 over 13.5 equals y over 6. Cross multiply. 54 equals 13.5y divided by. And I get y equals, what do you know? 4, which I already knew. So for the next one, we know the perimeter of KQV is 72, and we know that these two triangles are similar, so I can put 72 at the top of my proportion, or my ratio, sorry, and I can add all these up to find the perimeter of GHJ. It's 48. So again, this is my perimeter ratio right here. Okay, so my first, what I'm going to do is I'm going to solve for A. And A matches up with 16. And cross multiply. 72 times 16. 1,130. 52, 48a divided, a equals 24. So I know this is 24. The next one I can do is I'll do b, which matches up with 12. So I'll go b over 12. 72 times 12 is 864 equals 48b. Divide, b equals 18. And technically, again, we can make another proportion, but I know the perimeter of this triangle is 72. If I do 72 minus 18 minus 24 gets me 30 for this one, but I'm going to double check and make sure I'm right. 72 over 48 equals c over 20, cross multiply 1,440 equals 48c divided by, what do you know? It's 30. And these match up, so I know I'm right. All right, another one of these. So a scale factor is kind of like the ratio for all of this, what the difference is, like the ratio between these two in simplest form. So I could do 10 over 6, because we got to double check that we're looking at the triangle correctly. I have u, v, w, and I have x, y, z, so I know 6 and 10 match up. I know 15 and 9 match up. And I know 20 and 12 match up. I'm going to double check that these ratios all are the same. I can make this into 5 over 3. I can divide these both by 3 and get 5 over 3. And I can divide these both by 4 and I get 5 over 3. So these are simplest. 5 over 3 is my scale factor for these two triangles. Okay? That's how I got from this. I multiplied these sides by 5/3 and got to this. That's just saying how I got from this small one to this big one. The scale factor. How I scaled this to get bigger. Alright. So this next one. Suppose triangle SLC is similar to triangle GFR. And the scale factor of SLC to GFR is 2 over 3. Find the perimeter of GFR if the perimeter of SLC is 14 inches. So I need to make sure that my scale factor matches up with my perimeters. So it's SLC to GFR. So this top number is SLC and the bottom is GFR. So I'm going to do 2 over 3. And I'm going to make another ratio. I'm going to start with SLC, which is 14. And I'm looking for the perimeter of triangle GFR. So that's going to be x. And you guessed it, I'm going to cross multiply. So I have 2x equals, sorry again, I'm not great at multiplying in my head. 42 divided by 2 divided by 2. 21 is x. So that is the perimeter of triangle GFR. Okay? All right. And now I go over here. Same type of problem. Suppose triangle PQR is similar to triangle XYZ, and the scale factor of triangle PQR to XYZ is 5 over 6. Find the perimeter of triangle XYZ if the perimeter of triangle PQR is 25 centimeters. So I got to make sure my scale factor matches up with my perimeters. So I have 5 over 6 the 5 is PQR, and the 6 is XYZ. So it's telling me to find XYZ. So my X is going to be on the bottom, and my perimeter, which is 25, is going to be on the top. Cross multiply. 5x equals 150. X equals 30. So x equals 30 is going to be the perimeter of triangle X, Y, Z. Okay? That's number 5. Here's 6. Heather is using similar triangles to find the distance across Turtle Lake. What is the scale factor of triangle BCD to triangle ACE? So here are our two triangles. I have BCD, the small one, and I have a bigger one, ACE. Okay? So I'm going to take 15 over this. So I'm going to do 15, the smaller triangle, over 25 plus 15 is 40, over 18. Oh, actually, I'm doing too much. I'm doing more than I need to. I can go from here and find my scale factor. If I divide by 5, I get 3 over 8. So that will end up being my scale factor to get from this small triangle to this big one. If I wanted to solve for x, I could have done what I did earlier, where I had the 18 over x, because we don't know what this one is, to cross multiply, and I'd have 15x equals 720. And I would get that the length of this is 48 meters of this lake. This question doesn't ask for that, but I might as well show you that in case a problem like this comes up on anything in the future. Okay, now this last one, it looks really complicated, but it's not, guys, so let's just go through this really quick. And I'm going to circle important things. So a bird's eye view of the pentagon reveals 5 similar pentagons. Each side of the outside pentagon, so this big one, I know you can't really see my marker, is about 920 feet. So each side of the big one, okay, each side of the innermost, which is this small one, is 360 feet small sides. Alright, so it wants us to find the scale factor of the outside pentagon to the innermost pentagon. So if I make this a smaller fraction, let me do that really quick, and I get my scale factor to be 23 over 9. I used my calculator and made it into a fraction. Someone helped me, so I don't really know how to do it. So you guys can figure that out, but I got this scale factor, 23 over 9. Then it wants us to find the perimeter of the outside pentagon. We know each side is 920, so let's just multiply that by 5. We get 4,600 feet for the outer pentagon. And for the innermost, we're going to multiply this by 5, each side. I get 1,800 feet for the inner pentagon. And then find the ratio of the perimeter of the outside pentagon to the perimeter of the innermost pentagon. We know that the scale factor is going to match up with the ratios of the perimeters as well as the ratios of the sides. and vice versa. We know the ratios of the sides is the same as the ratio of the perimeters. So we know that the ratio of this is going to be 23/9. And I will just double check really quick. And I just checked on my calculator, and yes, this is the ratio for the perimeters of the two pentagons. So I think this was all pretty hopefully easy for you guys. We've done a lot with ratios and proportions, so I'm hoping that this is quick for you guys to understand and learn. If not, again, we have a worksheet tonight for homework, and we have a Zoom tomorrow, or if this is a Friday, Monday, whatever we end up doing. And we will go over homework and notes if you guys have questions. So I will see you guys next time for notes. Bye.